Welcome to our exploration of reflection and introspection in intelligent agents. In this video, we'll uncover how these advanced capabilities enable AI systems to not only perform tasks, but also continuously improve, much like humans do. We'll start by revisiting the basics of intelligent agents, their perception, reasoning, and action, and then dive into the emerging fields of reflection and introspection. These disciplines are pushing the boundaries of what AI can achieve, allowing agents to analyze their own cognitive processes, learn from experience, and adapt their behavior. By the end, you'll see how these concepts are transforming business and technology. Reflection in intelligent agents is about more than just completing tasks. It's about examining their own thought processes and learning from both successes and failures. This self-monitoring allows agents to adapt, improve, and make better decisions over time. Imagine an agent that, after a failed attempt, thinks, "That didn't work. Let me try another way." This ability to reflect is what sets advanced agents apart from simple input-output systems. In the next scenes, we'll see how reflection enhances decision-making, adaptation, ethics, and human-computer interaction. Reflective agents can replay past decisions and outcomes. Much like humans use metacognition, thinking about thinking, by introspecting on their decision-making processes, agents identify strengths, weaknesses, and biases, refining their approach over time. For example, a travel agent might analyze user feedback to improve future recommendations, learning which suggestions resonate best with different user profiles. This ongoing cycle of reflection and adaptation leads to smarter, more personalized decisions. Adaptation is crucial for agents operating in fast-changing environments. Reflective agents can introspect on their performance and adjust strategies as conditions evolve. Take the travel industry. If new travel restrictions arise, a reflective agent can quickly adapt its recommendations, avoiding affected destinations and suggesting alternatives. By monitoring user feedback and external factors, these agents stay relevant and responsive, ensuring users always receive the most current and suitable advice. Reflection also helps agents align with ethical norms and human values. In critical applications, such as autonomous vehicles or travel planning, reflective agents can evaluate the impact of their decisions, prioritize safety, and promote responsible practices. For instance, a travel agent might notice its recommendations are contributing to over-tourism and adjust to promote sustainable destinations. By continuously reflecting on their actions, agents can foster trust and act as responsible advisors. Reflective and introspective agents excel at interacting with humans. By deducing and responding to user emotions and preferences, they create more natural and engaging experiences. For example, a travel agent can adapt its communication style based on a user's emotional cues, being upbeat when the user is excited, or empathetic when the user is frustrated. This adaptability builds stronger relationships and enhances user satisfaction. Introspection is the process by which an agent examines its own cognitive processes, decisions, and behaviors. This self-analysis allows agents to identify patterns, detect flaws, and adjust strategies based on reflection. Introspection is key to evolving from simple task performers to adaptive systems that learn from experience, much like humans do. By evaluating their reasoning, agents can continuously improve and adapt to new challenges. Introspection enhances an agent's ability to handle ambiguity and uncertainty. By reflecting on past experiences, agents develop robust decision-making strategies for complex, dynamic environments. This capability is especially valuable in applications like autonomous systems, recommendation engines, and adaptive customer support, where flexibility and continuous improvement are critical for success. How do we embed reflective capabilities in intelligent agents? Several techniques are used, including traditional reasoning, meta-reasoning, self-explanation, and self-modeling. Each approach enhances the agent's ability to monitor, evaluate, and improve its performance. In the next scenes, we'll break down these techniques and see how they work in practice, especially in the context of a travel agent. Traditional reasoning involves logical, systematic problem-solving based on predefined rules or learned patterns. For a travel agent, this means handling user queries, like finding flights or hotels using set algorithms. While efficient for immediate tasks, traditional reasoning doesn't adapt based on outcomes or changing user needs. This is where meta-reasoning comes in, enabling agents to reflect and adjust their strategies. Meta-reasoning is the agent's ability to monitor and control its own reasoning activities. It allows agents to reflect on their decision-making processes and make adjustments as needed. For example, if a travel agent receives negative feedback about a recommendation, it can analyze why its reasoning failed and recalibrate its approach. This continuous evaluation and adjustment lead to more personalized and effective solutions. Let's look at a practical example. Suppose a travel agent recommends Paris, but the user is dissatisfied. Through meta-reasoning, the agent reduces the weight it gives to luxury in its decision-making for Paris. If the user is happy with a recommendation, the agent increases the relevant weight. This dynamic adjustment helps the agent refine its future choices, learning from every interaction. The Crew AI framework demonstrates how agents can be structured for meta-reasoning. In this setup, one agent recommends destinations based on user preferences, while another agent adjusts the internal weights based on feedback. This modular approach allows for clear separation of roles and continuous improvement, as each agent specializes in a part of the reasoning and learning process. With each user interaction, the agent refines its understanding of preferences. For example, if a user consistently prefers adventure, the agent increases the weight for adventure in its internal model. Over time, this leads to more accurate and satisfying recommendations, exemplifying the power of continuous learning and adaptation in reflective agents. Reflective agents monitor their own performance by tracking metrics like user satisfaction, recommendation acceptance rates, and complaint rates. By analyzing these metrics, agents can identify patterns such as consistently low ratings for certain hotels and adjust their strategies accordingly. This data-driven approach ensures that agents continually improve their effectiveness and user satisfaction. When agents notice trends in their performance data, like low ratings for adventure sports, they can adjust their reasoning strategies. This might involve incorporating more user preference data or diversifying activity sources. By responding to feedback and performance metrics, agents ensure their recommendations remain relevant and personalized. Meta-reasoning also enables agents to optimize resource allocation. For complex trip planning, agents can dedicate more computational resources to deeper analysis, while for simple requests, they use streamlined processes. This balance ensures efficient operation and timely responses, preventing overuse of resources for routine tasks and focusing effort where it matters most. Reflective agents use various algorithms for dynamic resource allocation, such as reinforcement learning, multi-armed bandit, and heuristic-based methods. These approaches help agents decide how much effort to invest in different tasks, ensuring optimal performance and personalized user experiences. By assessing task complexity in real time, agents deliver adaptive and efficient solutions. Self-explanation is the process by which agents verbalize their reasoning, making their decisions transparent and understandable. This serves two purposes: enhancing transparency for users and facilitating the agent's own learning. By explaining their choices, agents build trust and can also identify flaws in their reasoning, leading to continuous improvement. When agents explain their recommendations, users gain insight into the decision-making process. For example, a travel agent might explain that it chose a hotel due to its location, high ratings, and price. This transparency reassures users and increases their confidence in the agent's suggestions, fostering a stronger user-agent relationship. Self-explanation isn't just for users, it helps agents learn too. By verbalizing their reasoning, agents can spot inconsistencies or oversights in their logic. For instance, if a user is unhappy with a hotel recommendation, the agent can review its explanation and realize it overlooked a key preference. This introspection leads to refined strategies and better future decisions. Let's see how self-explanation works in practice. When a user asks for a hotel in Paris under $300, the agent not only recommends a suitable hotel, but also explains its reasoning such as proximity to attractions and price. This approach builds transparency and helps both the user and the agent understand the decision-making process. By reviewing self-explanations and user feedback, agents can identify where their reasoning fell short. For example, if a user wants a hotel closer to public transport, the agent can update its logic to prioritize this factor in future recommendations. This cycle of explanation, feedback, and refinement drives continuous learning and improvement. Self-explanations also make agent-user interactions more engaging and collaborative. By explaining their reasoning, Agents invite users to provide feedback, ask questions, or share more preferences. This two-way dialogue leads to more personalized and satisfying recommendations, as the agent continuously refines its approach based on user input. Self-modeling allows agents to maintain an internal representation of their goals, beliefs, and knowledge. This internal model is the foundation for decision-making and adaptation. As agents interact with users and environments, they update their self-model to reflect new information, ensuring their actions remain aligned with evolving goals and circumstances. A reflective agent's goals aren't static, they evolve as circumstances change. For example, if a user's travel dates or budget shift, the agent updates its goals to prioritize cost-effectiveness or adjust itineraries. This flexibility ensures the agent's recommendations always align with the user's current needs and preferences. Self-modeling also involves updating the agent's knowledge base as it learns from new experiences. If a user reports a negative experience with a hotel, the agent can adjust its knowledge, reducing the likelihood of recommending that option in the future. Conversely, positive feedback reinforces successful recommendations, making them more likely for similar users. Agents may have individual internal states or share a collective state within a system. Each agent can independently self-model or collaborate with others to maintain a shared understanding of goals and knowledge. This flexibility allows agentic systems to adapt to a wide range of scenarios, from solo assistants to collaborative teams. In practice, self-modeling enables agents to continuously adapt and refine their recommendations. As the agent's knowledge base grows, it becomes better at identifying user preferences and providing tailored suggestions. If it detects knowledge gaps, the agent can proactively seek new information, ensuring its advice remains accurate and up to date. Reflective agents are transforming business applications across industries. By applying self-assessment and introspection, these agents improve their performance in dynamic environments, making better decisions and delivering more effective solutions. Let's explore some real-world examples, from customer service to financial trading and e-commerce. Reflective customer service chatbots use self-assessment to improve their responses. By analyzing past conversations and user feedback, they identify strengths and weaknesses, refine their knowledge base, and adapt their communication style. This leads to more effective, personalized, and satisfying interactions for users. Personalized marketing agents leverage reflection to analyze consumer behavior and feedback. By studying buying trends and campaign results, they adjust strategies for future marketing efforts. Companies like Amazon use these agents to perfect product recommendations and optimize marketing parameters, ensuring better sales and customer engagement. Reflective agents are increasingly used in financial markets to enhance trading strategies. By introspecting on past trades and market data, these agents refine their algorithms, adapt to changing conditions, and mitigate risks. Hedge funds like Renaissance Technologies employ reflective trading agents to optimize decision-making and capitalize on market opportunities. Forecast agents use reflection to improve sales predictions. By analyzing past sales data and market trends, they adjust their forecasting models for greater accuracy. Tools like Salesforce's Einstein Analytics leverage reflective AI to deliver actionable insights, helping businesses allocate resources and plan strategies more effectively. Reflective agents optimize pricing strategies in e-commerce by analyzing competitor prices, customer behavior, and sales data. Companies like Walmart and Target use these agents to dynamically adjust prices, maximizing sales and profit margins while staying competitive in the market. Reflective and introspective capabilities are key differentiators for intelligent agents. By implementing meta-reasoning, self-explanation, and self-modeling, agents can monitor and control their reasoning, verbalize their decisions, and adapt goals and knowledge. These abilities foster transparency, trust, and continuous learning, leading to improved performance and user experiences. Implementing reflective capabilities in AI systems brings significant business advantages. These include better decision-making, more personalized user experiences, and a competitive edge through enhanced adaptability and learning. By continuously learning and optimizing, reflective agents help businesses stay ahead in dynamic markets. Reflection and introspection are essential for developing AI systems that emulate human intelligence. By analyzing their reasoning, learning from experience, and adapting behavior, agents develop sophisticated understanding and decision-making capabilities. These qualities are fundamental to building trustworthy, human-like AI. To recap, reflective agents use meta-reasoning to optimize performance, self-explanation to build trust and facilitate learning, and self-modeling to adapt to changing circumstances. These capabilities enable agents to continuously improve, delivering smarter, more personalized solutions across industries. While this chapter focused on reflection and introspection, the next step is exploring how agents use tools to supercharge their workflows. By integrating planning and tool use, agents can tackle even more complex tasks and deliver greater value. Stay tuned for a deep dive into agentic tool use and planning strategies. How do meta-reasoning capabilities contribute to an intelligent agent's performance? Meta-reasoning enables agents to monitor and control their reasoning, dynamically adjusting strategies and optimizing resource allocation. This allows agents to evaluate their thought processes, make real-time adjustments, and efficiently distribute resources where needed. What is the relationship between self-explanation and user interaction in AI systems? Self-explanation promotes transparent decision-making and enables natural interactions by allowing the AI to articulate its reasoning. This transparency builds trust and facilitates learning through clear communication. How does self-modeling contribute to an agent's adaptive capabilities? Self-modeling empowers agents to manage goals, update knowledge, and improve decision-making over time. This creates a dynamic learning system that evolves and adjusts its behavior based on new information and changing environments. What are the key business benefits of implementing reflective capabilities in AI systems? Reflective AI leads to improved decision-making, personalized user experiences, and competitive advantages through adaptability and learning. These benefits stem from the system's ability to continuously learn, adapt, and optimize performance. Why are reflection and introspection essential for developing human-like AI? These capabilities enable AI systems to analyze their reasoning, learn from experiences, and adapt dynamically qualities fundamental to human intelligence. Through meta-reasoning, self-explanation, and self-modeling, agents develop sophisticated understanding and decision-making that mirror human cognition.